Hey everyone, welcome. So, if you've ever just stared at your screen totally frustrated with code that's clunky, way too long, or just breaks all the time, you're going to love this. We're about to dive into Kotlin, a language that's pretty much designed to fix all of those headaches.
I mean, does this feel familiar? You're buried in a mountain of if-else statements. You think you've guarded against every possible null, and then, bam! That dreaded null pointer exception crashes your app anyway. It's a story every developer knows way too well.
But what if there was a language where safety and clarity were just built in, like part of its DNA? Well, that's exactly what Kotlin is. It's not just about learning some new syntax. It's about a totally different and frankly much smarter way of building software.
Okay, so let's get into it. For this explainer, we're pulling some amazing ideas from a really cool source called the Cosmic Kotlin Bilingual Reference. What's so great about it is how it uses these brilliant bilingual analogies that just make really complex ideas click. We're going to look at 4 of Kotlin's biggest superpowers, starting with how it completely changes the game for making decisions in your code.
First up, decisions. We're all used to the classic if-else chains or switch statements, but Kotlin hands us something that is just way more powerful.
Say hello to the when expression. Seriously, think of it like switch on steroids. It's not just for simple values. It can check against types, ranges, even the results of other functions. And it does all of this in a super clean, easy-to-read way.
And our source has this fantastic way to think about it. When is like a smart traffic junction. Instead of a messy series of stop signs and turns, it just cleanly directs your program down the exact right path based on whatever condition you give it. It's such an intuitive way to picture it, right?
And yeah, this picture says everything. Over on the left, you've got that tangled web of if-else blocks we've all written 1,000 times. But on the right, that's Kotlin's when. It's organized, it's clean, you can read it almost like a sentence. It's a perfect example of how Kotlin just swaps out confusion for clarity.
Now, that clarity we were just talking about, it isn't just for looks. It leads us straight into our next superpower, which is an absolute game changer, writing code that is fundamentally safer and just way less likely to blow up. You know, the null pointer exception has been called the billion-dollar mistake in programming. Why? Because of the insane amount of time and money we've all spent hunting down bugs caused by it. The people who made Kotlin basically said enough is enough, and they decided to solve this problem at the language level. And here's how they did it. It's so simple but so powerful. By default, nothing in Kotlin can be null. If you actually want a variable to be able to hold null, you have to tell the compiler by adding a question mark. This tiny rule changes everything. It forces you, the programmer, to deal with the possibility of nothing right when you write the code, which wipes out a whole class of bugs before you even hit run.
This whole safety-first idea pops up everywhere, like with typecasting. The old unsafe way, using as, will just crash your app if things don't match up. But Kotlin gives you a better option, the safe cast, as est. If it doesn't work, it just gives you back a null. No crash, no drama, just a predictable, safe result you can handle.
I love this analogy. The safe cast, as, is a polite cast. It's like you're politely asking the code, hey, is this thing a string? If it is, awesome. If it's not, no big deal, we just move on with a null. You're asking for permission instead of just demanding something and risking a total system meltdown.
Okay, our third superpower feels a little bit like actual magic. What if you could add new features, new functions, to classes you didn't even write, like without having to mess with their original code at all?
Well, in Kotlin, you totally can. It's called an extension function. This lets you literally bolt on new abilities to any class out there, even if it's from some library you just downloaded. It is such a clean and powerful way to build up your own set of helper functions that make your code so much more expressive.
And the mnemonic for this is just perfect. It's an add-on skill. You're not changing the original class at all. You're just teaching it a new trick. It's not invasive, it keeps things tidy, and your whole code base stays nice and organized.
So what does this actually look like? Well, it's pretty amazing. Instead of writing some clunky utility function like swap, mylist, index1, index2, your code suddenly becomes this beautiful, readable sentence, mylist.swap, index1, index2. It just feels like that swap function was part of the list class all along.
All right, for our last superpower, we're going to dig into something that really separates the regular Kotlin code from the pro-level idiomatic stuff. This is the good stuff. Let's talk about scoped functions. You've got let, run, with, apply, and also. Now, their main job is to let you run a block of code in the scope of a particular object. This helps you get rid of a lot of repetitive variable names and just makes your code structure a lot clearer.
Okay, I know this table might look a little intense at first, but it really just comes down to two simple questions. First, inside your code block, how are you going to refer to the object? Is it going to be this, where you can call methods directly, or is it going to be it, which is like a temporary nickname? And second, what do you get back when you're done? You either get the object itself back, which is awesome for setup, or you get the result of whatever your code did. That's it. If you get those two things, you've mastered them.
Let's make that real for a second. Take a look at apply versus run. You use apply when you want to set up an object with a bunch of properties and then get that same object back all ready to go. Perfect for initialization. But you use run when you want to do some kind of calculation on an object and get the result of that calculation back.
So a really great way to remember apply is to think of it as a self-customizer. You're basically saying to a new object, hey, here are all your settings. Go configure yourself. And when it's done, it hands itself back to you, fully initialized and ready for action.
So let's wrap this all up. We've just added 4 seriously powerful tools to our coding toolkit. We've got when for making smart, clean decisions. We've got null safety baked right in to make our code crash-proof. We've got extension functions to teach old code new tricks. And we've got scoped functions to write code that's super concise and professional.
You see how each of these features works together? It all comes back to Kotlin's main promise, to make you a more productive, happier developer by giving you a tool that's safe, expressive, and honestly, just a ton of fun to use. It's about writing less code that does more.
So I'll just leave you with this question. Now that you've seen what these superpowers can do, how is it going to change the way you write code? What kind of amazing things are you going to build with these tools? Now go make something awesome.